Good morning everyone. Today we are going to see Operating System Unit 2 Session 12. In the previous topic we have studied the concept Shortage Job First Algorithm, Non-Preemptive Scheduling Algorithm. In today's topic we are going to see Shortage Job First Preemptive Scheduling Algorithm. This algorithm is also called as Shortest Remaining Time First Algorithm. So preemptive scheduling means once the process is allocated to the CPU can be taken away in any situation from that particular process. So based on this algorithm, we'll see the problems. So first problem, they are given here the process number and the arrival time and the burst time. Now check out at unit 0 which process has arrived. Yes, at unit 0 process P1 has arrived. So at the beginning, there are no any other process which has arrived in the ready queue. So the first process which has arrived in the ready queue is process P1. So allocate the CPU for process P1 and its burst time is 8. So it is going to execute. See now, this is a preemptive scheduling. So there is an interruption in between. So the process P1 is going to execute till unit 1. And when the process P1 execute till unit 1, you can check out here. At unit 1, another process has arrived, that is process P2. So the burst time of this process P2 is 4. So already the process P1 is executing now, and out of 8 burst time, it has already completed 1 unit. You can see here it has already completed 1 unit. So total how many units are remaining here? 7. And another process has come here, P2, with burst time 4. Now you need to compare here the burst time of two processes. Now P1 is already executing and P2 has come with less burst time. So now you need to take the CPU away from P1 and give the CPU to process P2 because it has less burst time compared to process 1. Now process P2 is executing. Now the process P2 executes till 1 unit, 1 to 2. You can check out at unit 2 another process has come here, process P3, and its burst time is 9 units. Now process P2 is executing here. So out of 4 units, it has already executed 1 unit. So here 3 units are remaining. You can check out here, process P2 has already executed 1 unit. So 3 units are remaining. And another process has come here, P3 with 9 burst time. So now you compare this burst time. So process P2 only has the less burst time compared to process P3 which has arrived newly. So in this case you need to continue the execution of process P2 because it has less burst time compared to P3. So now again P2 is going to execute one more unit from 1 to 3. Now you check out another at unit 3. Another process has come here, process P4, and its burst time is how much? 5. Now process P2, it has already completed one more unit. So 2 units are remaining here. You can see process P2 has completed here 1 unit and here 1 unit. So out of 4 it has completed 2 units and still 2 units are remaining. And when P2 is executing, process P4 has come with 5 burst time. Now compare this burst time. The process P2 is already executing and the new process which has come, process P4. So compare this burst time. Process P2 only has less burst time. So you continue again with the process P2 only. So process P2 is going to continue here. Now you can check out at unit 4. Check out at unit 4 which process has come. There are no any other processes which has come. So you need to complete this process P2. P2 is already executing and there is no any other process which has come. Now in this case you need to complete the full execution of P2 because the CPU is with P2. So already out of 2, one more unit process P2 has completed, so only one unit is remaining here. So the last one unit, the process P2 will complete here. You can check out process this 1 unit, 2 unit, 3 unit and 4 unit. So process P2 has completed its full execution. Now process P2 has completed its full execution. So this process will be removed out from the list. Now how many processes are remaining here? Process P1 is remaining with burst time 7. Process P3 is remaining with burst time 9. And process P4 is remaining with burst time 5. Now compare these burst times of these processes. So which process has less burst time? Process P4. So allocate the process P4 here. Now there are no any further processes which are going to come. So you need to complete the full execution of process P4 because there is no any further interruption now. So how many units the process P4 is going to take? 5 units. So 5 plus 5, how much? Total 10. So P4 is going to execute till unit 10. Now which are the remaining process? P1 and P3. So compare the burst time. Process P1 has less burst time. So give the CPU to process P1 and it is going to execute till 7 units. So 10 plus 7. So process P1 is going to take 10 to 17 units. And one more last process, that is P3. So remove here one more box. So last process which is remaining is process P3. So how much unit it is going to take? Total 9 units. So 17 plus 9, it is 26. 17 plus 9, it is 26. So this is the allocation of the processes. So we have seen here at the beginning the process which comes first, that will be allocated to the CPU, and then how the processes keeps on coming, their burst time will be compared with each other, and the process which has less burst time, that process will be allocated to the CPU. Now further, when processes stops arriving in the ready queue, so the process which has less burst time will be given the CPU and they have to complete their full execution, and then the CPU will given to some other process to complete its full execution. So at the beginning there is an interruption, but once the processes stops arriving, then the processes, once it is allocated, have to complete its full execution. So this is the table. So this is the table of the problem, process numbers. This is the arrival time they have given, burst time which they have given. See the completion time. So the completion time of process P1 is here 17. So see here, completion time of process P1 here is, so the completion time of process P1 is here 17. P2 is 5 and P3 is 26. You can see here P2 is 5 and P3 is 26 and so on. So you need to find here now turnaround time, completion time minus arrival time. So you will get these values. Now waiting time, turnaround time minus burst time. So turnaround time minus burst time. So you will get these values here. Now you need to find out the average waiting time. So average waiting time divided by 4, you will get 6.5 millisecond. Similarly, turnaround time divided by 4, 13 milliseconds. So next problem we'll see example 2. They are given here the process number, arrival time and the burst time. So check out at unit 0 which process has arrived. Process P1 has arrived and its burst time is 7. So at the beginning there are no any other processes in the queue. So allocate the CPU to process P1. So P1 is going to execute from unit 0 to unit 1. Then immediately at unit 1 another process has come, process P2. Now process P1 is executing, and out of 7 it has already completed 1 unit. So 6 units are remaining here, and process P2 has come with burst time 5. Now compare this burst time. So process P2 has less burst time compared to process P1. So allocate the process to P2. Now P2 is going to execute till unit 2, and immediately at unit 2 another process has come here, process P3, and its burst time is 3. And here already the process P2 is executing. So out of unit 5 it has completed 1 unit. So 4 units still are remaining here. Now process P3 burst time is 3 here now. So compare this. So process P3 has less burst time. So allocate the CPU, take the CPU from P2 and give the CPU to P3 because it has less burst time. Now process P3 is executing. It will execute till unit 3, and immediately at unit 3 another process has come, process P4, and its burst time is 1. And now currently P3 is executing. Out of 3 it has completed 1 unit, so 2 units are remaining here. New process has come with burst time 1. So compare this burst time. So process P4 has less burst time. So allocate the CPU for process P4. So process P4 is executing. Now as process P4 has only 1 unit, so it has completed its full execution. This process P4 has completed its full execution. Now at unit 4 another process has come here. You can check out at unit 4 which process has come. Process P5 has come with burst time 2 unit. Currently P4 was executing here, which has already completed. Now process P2 has come here with less burst time 2, with burst time 2. Now you can already check here. Process P1 has 6 burst time, process P2 has 4 burst time, and process P3 has 2 burst time, and process P5 has also 2 burst time. So process P3 and process P have same burst time. Now if you have same burst time, check out which process has arrived earlier. So process P3 has arrived earlier and it is waiting. So we allocate the CPU to process P3 here. So process P3 is executing. So process P3 will execute till unit 5. And out of this 2 unit, it has completed 1. So remaining there are 1 unit. Still remaining there is 1 unit. So at unit 5, another process has come here. Process P6. And its burst time is 1. So now when you compare here, P3 is already executing. It is still has to execute 1, and new processor has come with 1 unit. So same burst time you have. So which has arrived earlier? Process P3. So continue with process P3. Continue with process P3 here. That is from P3 to P6. 5 to 6. P3 is going to execute. Now process P3 has also completed its full execution. So this will be removed out from the list. Now check out at unit 6 which process has come. At unit 6, yes, there are no any further process which has arrived. So you need to now check out the burst time of the processes which have already arrived. So the process P1 has 6, and the process P2 has 4 burst time, and the process P5 has 2 burst time, and process P6 has 1 burst time. So check out which process has less burst time. Process P6 has less burst time. Process P6 has less burst time. So this will be allocated to the CPU P6, and its unit is only 1 unit. So 6 to 7. So even process P6 is completed. So till now which is remaining? So this is remaining with process with burst time 6, and this is burst time 4. This is burst time 4, and this is with burst time 2. So process P5 has less burst time, so allocate the CPU for process P5 with 2 units. So 7 plus 2, 9. So even this is completed. So only 2 processes are remaining here with burst time 6 and 4. So which process has less burst time? Process P2. So allocate the CPU for process P2. Its unit is 4. So 9 plus 4, it is 13. So last burst time is remaining is process P1 with burst time 6. So 13 plus 6, it is 19. So at the beginning, the process which has arrived at 0th unit, that process will be allocated. Then depending on how the processes keeps on coming unit by unit, check their burst time. The process which has less burst time, allocate the CPU. So once the all processes stops arriving, there are no further processes which are arriving, then you complete the full execution of the processes once it is allocated. So this is the table of that problem. Process number, arrival time, burst time, and this is the completion time we get. Turnaround time we find, waiting time, and this is the average waiting time 7 milliseconds and average turnaround time 4 milliseconds. So in today's session we have completed SJF algorithm using preemptive scheduling algorithm. In the next session we will see some new algorithm. Thank you.